Alright, today we will do testing of the RX888 Mk2. This testing result will be driven by data and no bullshit. I'm your presenter, Dr. Moonshine. Again, this video is strictly going to show you testing results for the RX888. If you want to see an unboxing video and how to set it all up, go see the Tech Minds video. And 5 minutes in, after he finally takes it out of the box, he's going to show you how to get it going. But this video is going to be a technical test of how well the RX88 Mk2 performed. Just so we're all on the same page, this is what I'm going to be talking about. You can get them on eBay for anywhere from $160 to $180. They're all the same thing. So if you want to buy this after this video, that's where you go get them. What did we use to test this? We used the Rohde & Schwarz SMW 200A. Frankly, it's the standard. No more questions. To be clear, the software we used was SDR Console version 3.2. The PC that the software ran on, Windows 10, 32 gigs of RAM, Intel i7 running at 2.6 gigahertz clock. Time for the bad news, folks. The RX888 Mk2 still has spurs. I assume they're clock spurs, but just because they're kind of integer, sub-integer harmonics of the ADC clock, which was running at 64 megs. So as you can see here, we got spurs at 8, 16, a fairly strong one at 24, and some other guys up there between 26 and 28. So just letting you guys know, this is not crystal clear spectrum, as the previous version also had these same problems. The RX88 front-end control, here's the screenshot. You got an HF gain that you can wobble up and down. You got an attenuator now. You can apply 10 or 20 dB attenuation and all the good stuff. So for my testing, we're running the ADC at a 64 megahertz clock. The firmware version was 2.2. Inside the SDR Console GUI, we have a nice little write-up here of the details of what's going on with the analog to digital converter. And one thing I really liked about this is they have some magic here where they're constantly correcting the ADC clock and adjusting for its errors. So I was quite impressed to see this. I don't know if this is a function of SDR Console or the RX88, but in either case, very impressive and well done, whoever did all this. And just to prove how good the clock accuracy is, we told the RX88 to be tuned to 27.185 upper sideband, and the signal generator was placed basically 200 hertz above that. And as you can see in that spectrum there, the tone is exactly at 200 hertz. So bottom line, this will be a very good SDR for those of you using or listening to single sideband signals. The source of the error will most likely be the transmitter, not the receiver in this case. So Dr. Moonshine approves the RX88's frequency accuracy. Noise floor. Noise floor was about 130 dBm. Minus 120, I heard the tone. At 130, it was gone. I would say for a realistic, decent copy, probably negative 110 dBm is the realistic MDS. And as I mentioned here in the slides, the AirSpy HF Plus Discovery still wins it again. And maybe I'll do a video where I put the AirSpy through its paces, but nothing, as far as its noise floor, nothing beats the AirSpy HF Plus Discovery. The RX88 does get warm. I wouldn't say it's like hot, but it is getting warm, so probably not a bad idea to have a fan or something next to it. For serious users out there, maybe you want to place it in the freezer, because as the formula shows, the noise power is based upon temperature. See, I kind of know some things. All right, here's the picture here. So the signal coming in is at 120. There you can clearly see it. And once it goes down to 130, we don't see it anymore. So for all intents and purposes, 120 is about as low as you're going to be able to see. Here's the bad news for this. Low-pass filters are a must. They have, I don't know if it was a software bug or the hardware itself, but this unit suffers from extreme aliasing. And let's get into the details here. So again, the ADC is running at 64 megahertz clock. So knowing that, I injected a signal at 65 megahertz at negative 100 dBm. And what I'm looking for is, do I see a signal at 1 megahertz? In other words, did the 65 megahertz signal alias down to 1 megahertz? And the answer is yes, it did. So low pass filter in front of this will be a good idea for those of you seriously considering buying this. And here's data and proof just to show you I'm not bullshitting. Again, into the unit is a 65 megahertz signal at 100 dBm power level. And I tuned the RX888 to 1 megahertz, and there you clearly see the tone at 1 megahertz, which is the alias signal. I then install a 5 megahertz low pass filter in front of the unit, and the 1 megahertz signal is gone. So, for those of you thinking it was my signal generator, well, that 1 megahertz tone should have still been there after the low pass filter was installed. Since it went away, that clearly tells me what we're seeing here is aliasing or Nyquist zones. If you're not sure what all that is, go see my videos where I talk about that. Again, I actually know a few things. And what other YouTube channel is going to be able to show you this? So, we had some fun with it. We put a little waterfalls in the thing. So, there you go. All right. So, bottom line, I would say for under 200 bucks, it's not a bad SDR. I would say the nice feature of this thing is it lets you see 32 megahertz instantaneously. If that's something you find cool or need, well then I think this unit is for you. Again, low pass filter is needed, so 30 megahertz, 20 megahertz low pass filter would be a really good idea for those of you that are going to seriously use this thing. Now, it's an HF unit, but you can, with some custom down convert some high frequency signals down to this thing and get effectively 32 megahertz of bandwidth. So that's a pretty neat application. Maybe I'll do a video on that just to show you, what Wi-Fi signals look like and all that kind of fun stuff. All right. See the band conditions. This would be a good SDR to do that. If you're really looking for low noise detection, my book, my opinion, my testing shows that the AirSpy HF Plus Discovery wins most SDRs by a long shot. MDS for the AirSpy HF Discovery is often down at negative 145 dBm, and that is incredible. Now, what other clowns on YouTube do is they hook some shitty LNA in front of that and say they have the same performance. That's where they go wrong. You can't blame them. They just don't know what they're doing. Anyway, back to the RX888. Some good antennas for this would be a loop on the ground antenna, the mini whip, the U-loop, which is a great little thing, and probably without the LNA. And for serious government users, an HF loop array would be a great choice. Again, there's a video, short, sweet, details, measurements shown, brought to you by Budweiser Nitro Reserve Gold. Thank you for watching. If you want to see more videos like this, subscribe to the channel. Again, this has been a production of Moonshine Radio. Thank you for watching.